Hello, pre-algebra classes coming at you, not live, I guess recorded from my house in North Raleigh. Um, Today we're jumping into lesson 6.31 and we're getting out of ratios and unit rates and into proportions. So today we're going to solve proportions, figure out what proportions are first and foremost, but we're going to solve them by writing an equation of cross products. Then we're going to write a proportion to solve word problems dealing with finance, maps, scales, models, recipes, road trips, etc. So explaining the world with middle school math, once again, that is our job. So a proportion, if you didn't know or didn't recall from sixth grade or seventh grade, or it's a recurring and spiraling theme in middle school math, but a proportion is simply an equation of two equal ratios. It is saying that one ratio is equal to another ratio. So, for example, remember uh, that um, ratio is a comparison of two numbers by division. So, for example, if you had the ratio of 4 cats to 5 dogs, an equivalent ratio would be 8 cats to 10 dogs. The ratio is still the same. If you divide 4 by 5, you get 0.8. And if you divide 8 by 10, you also get 0.8. So when a ratio is equal to another ratio, it is called, you guessed it, a proportion. Fancy math words, proportion. Okay? And there is always some common factor that multiplies the numerator in this equation and the denominator in the equation. We call this the proportional factor or the scale factor. Okay? There's an IXL module that calls it something weird and nerdy. They call it what did they call it? The constant of proportionality is what the IXL module called it. But we're just going to go ahead and say the proportional factor. And what is the proportional factor in this one? Well, the proportional factor is 2, because to scale up the number of cats, you multiply by 2, and to scale up the number of dogs, you would multiply by 2. Or going the other way, you could say you're dividing by 2. Either way that you slice that cake, it's true. The proportional factor in this case is 2. Okay? So, this interesting fact, when you have two fractions that are equal to each other, two rational expressions, two ratios, if it is a proportion, a true proportion, and they are indeed equal to each other, their cross products will be the same. Their cross products will be the same. So to test for proportionality, let's multiply to see if the cross products are indeed the same. Okay? So if this is a true proportion, like the last one was, that means this cross product, cross multiply, that means the numerator of the right-hand side fraction ratio and the denominator of the left-hand side, when I multiply those two numbers, that should come out to the same exact product as if I were to multiply the other two numbers. Let's check. So 3 times 26. Okay, well, 3 times 20 is 60. 3 times 6 is 18. 60 plus 18 is 78. Okay, let's check 39 times 2. Okay, or 2 times 39. The product is still the same. So 39 times 2 is also 78. So this one is a true proportion, meaning that um, 2 to 3, or 2/3, is an equivalent fraction to 26 over 39. You probably knew that by just simply looking at it. But this cross products um, phenomenon is going to become very handy to us very soon when we do a little algebra here. Let's check the next one. Is 4 to 7 the same thing as 12 to 25? Is 4 boys to 7 girls the same thing as 12 boys to 25 girls? If you're unsure because they seem like they're close fractions, check the cross products. 7 times 12 is 84. And 4 times 25 is obviously 100. So this one is a no, false. That is actually not a proportion. The whole equation was a lie to start from. Okay? So when you're solving a proportion, algebraically, if there's an unknown part of the proportion, we can use the fact that cross products are equivalent to rewrite and solve. So if there is a variable or a variable expression, monomial or binomial, in either the denominator, numerator, or denominator, you can use this cross product equation to be able to go ahead and solve. So, for example, x parts to 8 is equal to 5 parts to 4, and this one's probably mental mathable, I get it, okay? But let's write an equation of cross products. So, if I knew nothing else about this proportion, you could know that 4 times x must be equivalent to the other cross product, 8 times 5, and that's where that 40 came from if you were unsure, okay? So 4 times x is 4x. The other cross product is 8 times 5. I can know, based on this being a proportion, that those two things, those two quantities, those two cross products are going to be equivalent. All right, and now I have a one-step equation to solve, and I will solve with just simply a inverse operation of multiplication, which is, of course, division, and find that x is 10, like you always knew it was. Okay, but let's actually level up the difficulty here. All right, solving a proportion that has a binomial in it. Okay, cross products are still going to work with a binomial like x plus 4. Okay, but I can, in this case, I must recognize that this numerator is a group. Okay, so I can know that 8 times 3, little circle graphic is a little off there. 8 times 3 is 24, is my one cross product. And the other one is going to be 2 times whatever x plus 4 is, okay? And 2 times, in parentheses, x plus 4. And I don't know why I rewrote what was already written there for you, but you get the point, right? This cross product is equal to this cross product. Now, even as the directions say on this note slide, distribute as necessary. I am going to have to go ahead and use the distributive property to say that is 2x plus 8 is equal to 24. Subtract 8 from both sides to undo the adding of 8. 24, take away 8 is, of course, 16. I will undo the multiplier, that constant, by dividing by 2, and I should find that x is 8. And you can still plug these in to see if it works. Okay, still plug these in to see if it works. So 8 plus 4 is 12. Is 12/8 12 to 8 the same ratio as 3 over 2 is? Well, you could divide the numbers to find out that they're both 1.5, or you could check the cross products again. 8 times 3 is 24, and 12 times 2 is also 24. So we have checked our solution, and it does indeed check out. Okay, let's pause the video. I want you to practice solving here. See if you can solve these with an equation of cross products. I'll pause the video. You do the same. Okay, on the first two practice problems, I found the one cross product was 20 times 3, which was 60. The second cross product would be 4 times x, which is 4x, of course. One step of inverse operations, and you're done. X is 15. 24 times 3 is 72, and 8 times y will be algebraically 8y. And then I'm going to undo the multiplier by dividing, okay? And y is equal to 9. Let's go on to the next ones. So see if you can do them with first of all, a monomial 2g, and then the second one, a binomial y plus 1, and figure out what y and g are, respectively. All right, so on the first one, I multiplied 24 times 2g to get 48g, and then 8 times 18 to get the other cross product, which was 144. I set them equal to each other, and that's really useful to know that cross products are equivalent. And then divide by 48, and g is positive 3. On the next one, right, I have this binomial in it. Make sure that you break out the distributive property. 5 times y plus 1, you need to break out those parentheses. This is a group up top. So 5 times y plus 1 is our one cross product, or I should say, more mathematically astute, 5 times the sum of y and 1 is equal to 25 times negative 3, which is negative 75. I'm going to go ahead and distribute my 5. Make sure you distribute it to the y and the 1. most commonly missed Unit 5 problem was just simply because people forgot to distribute to the second number on one particular problem for whatever reason. Anyway, I regress. Start your solving process. You should have negative 75. Take away 5 is negative 80. And then I'm going to divide by 5. And let's see if you got it as well. Y is equal to negative 80 over 5. Remember your negative signs, negative 16. It's kind of hard to write on the screen when it's vertical like this, but that's okay. Okay. Last ones, and then we'll call it. Is that the same problem that we just did? Yes, it is. All right, we don't have to do this one. Our work's already done there. Wonder how that happened. Let's do this one where n is in the denominator though. 8 divide n is equal to 1 over 4. What could n be? Let's use a cross product equation to figure it out. Okay, and even when n, the missing variable, was in a denominator, you can use this cross product equation, the equation of cross products, to be able to solve for any missing component no matter where it is. So hopefully that gives you a good insight of how to solve a proportion, right? Now, if you end up with a word problem, just FYI, and you will, we're going to be doing these from time to time, okay? We're going to write one ratio with the information given and set it equal, if there's an equation sign, it's called a proportion, with the other information that you've been given. So we'll do one word problem and then call this lesson a thing. Jason made 5 baskets for 9 free throw attempts in last night's basketball game. At this rate, if he doesn't get any better or any worse, how many shots would he make if he hypothetically took 81 free throw shots? Okay, so these are the made 2 attempts. So let's make sure that I have 5 to 9 is the first ratio that the problem gives me. And this is 5 made baskets with respect to 9, what we'll call attempts, ATT. Okay. And then on the other side, you have to say, okay, is this 81, is that a free throw attempt or is that the made shots? Okay, and it's asking how many made shots or how many shots would he make if he took 81 free throws. So that is referring to, just by context clues, that is referring to a number of attempts. Okay, and then if you solve this with an equation of cross products, you would have 9x being equivalent to 5 times 81, which is 5 times 80 is 400, plus an extra 5 should be 405. Okay, and then we're going to have to divide by 9 on both sides. Divide by 9 on both sides, and x is going to be equal to 45. Let's put it back in context just to see if it makes any sense. Okay. 5 made shots to 9 attempts. Is that equal to 45 made shots out of 81? And yes, it does. I could put it back in to see if my cross products are equivalent, but also this thing called the proportional factor is relevant now. 9 got multiplied by 9 to get 81, scaled factor. And then 5 gets multiplied by that same number, 9, and 5 times 9 is indeed 45. All right, so that is proportion and proportion solving. Don't forget to like and subscribe. I will see you later.